I'll carry on.
Okay. All right, so let me go ahead and get started here. We are looking at 6.1.
Yep.
And 6.1 is a really nice section. Let me give it a title instead of just writing 6.1. Okay, so we are looking at 6.1, which is about radical expressions and functions. Now we're looking at radical expressions and functions here. So what we're doing here is we're looking at this square root. Or how about we call it, to start with, this principal square root. Right, its notation or its symbol, right, looks something like this. And what this principal square root means, it tells us that we're going to get a non-negative number. Right, you even notice that your calculator has that key. Right, even your calculator has this key here. So we can take a look at some examples here. Right, this square root of 25. Right, and really understanding that this just means what number can be multiplied to itself to equal 25. That's what this square root symbol means. All right, what number can we multiply to itself to get 25? So here we should see that the square root of 25 equals 5, right? We can check our work, right? If we multiply 5 to itself, we see it gives us this answer of a 25 there. You can put that in your calculator and see it gives you the same thing. How about find negative square root of 9/4? Means the same thing. What number can we multiply to itself to get 9/4? Once again, you can put this in your calculator and get that answer, but we should see that our answer here, well, first, order of operations says we do this, right? Well, what number can we multiply to itself to get 9? That's a 3. What number can we multiply to itself to get 4? Well, that's a 2, right? And then we bring the negative sign down. So this here is our answer, right? 3/2 times 3/2 gives us a 9/4. over 4. Right, so another nice example. I really encourage you to be comfortable with your calculator, right? Some nice examples I should be able to use for the calculator. Well, how about this one here now? I say to find the square root of a negative 25. Well, here you'll see that this is not possible, right? This here gives you, it will give you something that on your calculator, if you put in, it says error, right? This does not give a real number. Once again, it makes sense because 5 times 5 gives you 25, and it is not negative 25. And if you do negative 5 times the negative 5, it still gives you 25. All right, so having a negative inside the square root symbol is not a possibility. Any questions so far? Okay, so let's take a look and continue on. Right, what we can also do, right, is we can evaluate. We can evaluate them. Right, I give you this function, which is a square root of 2x minus 6. All right, I'll give you this function, which is a square root of 2x minus 6, and I want you to find f of 7. Right, so in order to find this, all we do is replace x with 7 and follow order of operations. Right, so what do we get? 14 minus 6. Because 2 times 7 is 14. Right, this here gives us the square root of 8. You should be able to input this in your calculator and also get a decimal, right? So if we put the square root of 8 into our calculator, what do we get here? We get something like a 2.828. We round it to, let's just say I said the hundredths. It'd be something like 2.83. Right, so a nice example of evaluating functions with square roots. All right. And since we're on the talk of functions, another thing that we can do is we can find domains of functions, right? And in order to find these domains, all you do is set the inside to be greater than or equal to 0 and solve. All right, so what we do here is we set the inside to be greater than or equal to 0, and we solve it. Right? So we add a 1 to both sides. Divide by 2. Right? This tells us that our domain, right? Our domain is a set of x where it can be every single number that's greater than or equal to 1 over 2. Right, so a nice example of finding the domain of a square root function. Any questions? All right, moving on then. We can simplify these expressions. One thing to keep in mind is that the square root of a to the power of 2 equals the absolute value of a. So something like the square root of, open parentheses, negative 16, close parentheses, to the power of 2. Right? Kind of looks like that. We say that's our answer. Right? Equals absolute value of negative 16, and the absolute value of negative 16 is just 16.
Will you give the answer after we complete the absolute value? Do you still have to put it back in the absolute value signs?
No, because this one, if you can work it out, no, because you can actually do the absolute value of 16, right? But another example, right? Another example may be like, let's say, how about the square root of 36x to the power of 2, right? Well, keep in mind that what this rule tells us, the inside has to be to the power of 2, and here it's only x that is to the power of 2, right? So what we can do with something like this, we know that 36 is just 6 to the power of 2, right? So we can rewrite this then as open parentheses, 6x, close parentheses, to the power of 2. Now it looks like our rule, and we can say, well, then this just equals the absolute value of 6x. But we're not done here, right? What we can say here is that this is really the absolute value of 6 times the absolute value of x. And what we can actually do is the absolute value of 6, which is just 6, and we bring back our absolute value of x. So the only time you bring back, or the only time the absolute value stays on there, is if you're working with the letter. But if there's a number in the inside, well, then you actually do the number, and you can see absolute value is gone. So does that make sense and answer that question for you? So another example then just like that too. Right, how about the absolute value, open parentheses, negative 5c, close parentheses to the power of 2? Here we see that this entire thing has a power of 2. So then we can say that this is just absolute value of negative 5c. Right? But then we can rewrite this as the absolute value of negative 5 times the absolute value of c. And now we can actually do the absolute value of negative 5. So it's 5 times the absolute value of c. Any questions? Okay, let's continue on here then. Right, and what we'll start looking at next then is cube roots. Cube roots are in fact a little different, right? A cube root is written as this. And be very careful. It is a small 3 inside this symbol. It is not 3 in front of it, then a. That is square root. This 3 has to be in the inside. Understand that. The 3 is in the inside of that little symbol, not in front of it. Here you can clearly see there is nothing inside there. When there is nothing inside, it's square root. But it is similar to square root. Square root meant what number can you multiply it to itself twice? This means what number multiplied to itself 3 times gives 8. Right, so that's what cube root means. You also have a key in your calculator like that you should get familiar with. You can easily input that in your calculator and you get an answer of 2. Once again, you can check it. 2 times 2 times 2 gives you 8. And if you need help with using that function on your calculator, I'd encourage you to set a meeting with me. Won't take long, about 5-10 minutes, and then I can show you, because I would have to see you with your calculator. I can guide you on that. And then also, not only do we have cube roots, but I mean, what we can see is we can see any type of roots, right? We can see any type of roots, right? So we can have odd or even kth roots, right? the kth root of A. It can be any number. And still implying the exact same thing. The 5th root of 32. This again means what number can be multiplied to itself 5 times to equal 32. So we should see that this answer is 2. Because 2 times 2 times 2 times 2 times 2 gives us 32. And you can use your calculator to check your work, because your calculator has a button where you can put any number in there. Sometimes maybe it looks like this on your calculator. Once again, if you need help with that, I would encourage you to schedule a one-on-one meeting so I can help you with that, because every student does have a different calculator.